In this video, we're going to talk about vector subspaces. Let V be a vector space such that W is a non-empty subset of vector space V. If W is a vector space under the operations of addition and scalar multiplication as defined in V, vector space V, then we say that W is a subspace of vector space V. Suppose we have some set W where W contains x sub 1, 0, and x sub 3. Where x1 and x3 are real numbers. And we'd like to show that W is a subspace of R3 with the standard operations. So how do we do this? Well, first, we need to make sure the set W is non-empty. Here we see W is non-empty because it contains the 0 vector. The 0 vector (0, 0, 0). In other words, W lies in the xz plane. Now we check for closure under addition. And we find that this must be true, since, for example, we have x sub 1, 0, and x sub 2, plus y sub 1, 0, and y sub 2, where each lie in the xz plane. We can see that this sum is an element of set W, since the result will also lie in the xz plane. Now we check for closure under scalar multiplication, and this will work since some constant c times x sub 1, 0, x sub 3 is equal to c times x sub 1, 0, and c times x sub 3. So the closure property holds. After checking to ensure that W was non-empty and that the closure properties hold, it would be necessary to check the other 8 properties which we discussed in the previous video. As long as those are all satisfied, then we can say set W is a vector space. And for this particular example, they would all be satisfied, and we could confirm that W is a vector space of V. The process is pretty straightforward, if not a little time-consuming. And this concludes our example of the definition of a vector subspace.